I almost dropped my phone. Wait, check the stream on another device. Let's see. Should be live. We should be live. Or not. Are we? Are we? No. Phew. Okay, so sharing a screen. Okay, should be live. I don't know which filter. Which filter do you like? You can do a channel swap. Channel swap? Do you like a channel swap? Anyhow, yeah, everything we do is available on BioniChaos.com. Go check out the website. Let me know what you think. Let me know what you think. One sec. Okay, so I have a bunch of tools on the side for your convenience. What happened to my gain? Something happened with my gain. Okay, now it should be okay. Can turn yellow. I don't know, maybe yellow. Can do purple. Do you prefer purple? Yeah, yellow will be hard because RGB. I can do RGB, GBR, so green. Can do BRG, BGR, GRB. That's pretty much it. Wait, can set the amount, but the amount doesn't change anything. What? Yeah, well, I could do more on this web app. Oops. Yeah, make web applications like this live on the stream. On the stream. Check. So yeah, so if you have any comments, go check out the website. Let me know if there are any questions in the chat. Had some other tools as well. Had some other tools as well. Yeah, let me know if you check them out. Let me know if any specific tool is of interest. We can go and dig deep into it. Otherwise, we have many more in the development. Similar tools like that. Wait, where's the Visual Studio Code? Visual Studio Code. So what's loading? Quite taking some resources to load. That should be fine. Ah, and a new version. Yeah, new version. What can you do? OS integration, blah blah blah. Developer productivity, agents, tools. Yeah, we are using the agents, obviously. Well, not obviously, but we are using the agents. MCP. Yep. Yeah, I think it's all the standard stuff. We actually have them turned off at the moment. Code completion so fast. Yeah, they are turned off. Well, because yeah, we're using too many tokens, whatever. Delegate to Copilot. Okay. So we had a bunch. We have this Python script actually checking the website. To run it for a sec. It only should take 5-10 seconds. Generating all the errors and things. If there are any errors, missing stuff. You have like more than 100 things to fix. Let's see. CPR. Direct chatbot. Half of them I don't even remember what it was. The phase blood simulation. Yeah, so we deployed that one. It's called real-time signal amplification microscope. Yep, so that one's working. Yeah, the camera is used by a different tool. We can test it later. Now you can load it. We can load it. Instead of the camera filter. We can load it instead of the camera filter for a sec. Where's OBS? We have the virtual camera. What's the virtual camera? Real time. Yeah, we can do this one. What's the... It's loading differently on different browsers. It's something we have to... check. But it is measuring... It's noisy signal. it's doing okay. Yeah, we're live. Should be live on YouTube. If you everything will do eventually available on BioniChaos.com. Go check out the website. Let us know what you think. Just forgot my microphone. Forgot my microphone. The system keeps adjusting my gain for whatever reason. Keeps reducing my gain. Why is it reducing my gain? Okay, now it should be fine. Share the screen with the bot. What's called live? Studio, google.com, live. Live. To share the correct screen. Have to share the correct screen. So we are developing web applications. We are developing web applications. I'm talking to AI. Talk to Gemini. Well, what do you see on the screen real quick? Can you describe what's on the screen? It's a website we're developing, by the way. So go check it out and describe what you see on the screen real quick. I will do more details on it. Wait, I'm getting messed up with all the microphones. One sec. Okay, I'll just let the robot.
This website, BioniChaos, offers a variety of interactive simulations in biomedical engineering and neuroscience. You can explore topics from robotic arms to brainwaves, making it a great resource for students and researchers. It seems like a fantastic place to learn about these complex fields in an engaging way. I encourage you to check out the website yourself to see what catches your eye.
Yes, it was Gemini. Do you like the voice? We can change the voice. We can change the voice. Wait a sec, wait a sec, wait a sec, wait a sec. It will start talking again. You can continue the stream without the screen, maybe, without sharing the video, maybe. Without sharing the video. The BPM is incorrect. The BPM is incorrect. The BPM is not correct. The BPM. The BPM is incorrect. What's happening with my gain? Keeps dropping the gain. It's really annoying. Okay, let's jump into development. Just do development. We'll just do development. I'll have another AI studio running. Gemini 2.5 Pro. 2.5 Pro. And this one on histology. I'm sure it can generate very well, not accurate, but like realistically looking histopathology slices. I mean, in general, AI can. This is one of the really old models. I'm pretty sure it can do much better these days. I mean, they're not accurate; they're just fake. And fake in the sense, I don't know what is fake. I mean, they look hyper realistic. They look hyper realistic. If we give it to a histopathology, yeah, I wonder. They'll be spending a lot of time understanding what it is. Obviously, it's nothing. It's by the way, same with other biomedical imaging. Biomedical imaging. Yeah, so I have this say interactive MRI simulator. Sound is on. Yeah, it just does this proton spin simulation, applying field, RF pulse intensity, brain slice, showing you 10 slices. They're obviously fake, there's something in it. Yes, you can play with it yourself. Most applications now, they will have their own a demo mode, but then if you interact with the thing, you can just set things by yourself. Yes, so the pulse intensity in this case will generate a small spin, or you can generate a much larger spin. We can just use the demo. Maybe with sound off. Sound is pretty repetitive. It's pretty repetitive sound. So I was saying histology is pretty much similar to how you generate, well, any biomedical imaging would be pretty good at it. Question is, yeah, defining what's fake, what's not fake. Histology. Well, this one, it didn't have anything interactive to it. Essentially, just what's called the text. So just a blog over there. But how do we turn it into? How do we turn it into something more interactive? So give it to Gemini for a sec. Now we need URL context. Beep. The URL is correct. What are you talking about? Ah. Let's chat to. Let's do perplexity. We haven't done perplexity for a while. Can you explain histopathology in one sentence? Hey, can you give a technical summary for the histopathology, how it's being conducted? Make it real brief, and also mention how would we do a web simulation around it.
Histopathology involves collecting tissue samples, fixing them in formalin, embedding in paraffin, slicing into thin sections, staining, and examining under a microscope for abnormalities. Web simulations can be conducted using specialized software platforms that mimic histological processes.
Okay, I'm particularly interested in not the preparation, but the actual data processing after we have the image.
After imaging, histopathology data processing includes digitizing the images, applying algorithms for tissue segmentation, quantifying features like cell density or morphology, and using statistical models for diagnosis or prognosis. Web simulation tools can assist in visualizing these computational steps.
Now, so if you had to develop a simple web application for it from scratch in the browser, how would you go about it?
To build a simple web app for histopathology in the browser, you'd set up a front end with HTML, CSS, JavaScript, use a library like OpenSeaDragon for image handling, process data with WebAssembly or TensorFlow.js, and handle backend processing with a lightweight server in Node.js or Python. You'll also integrate APIs for simulation and analysis.
Okay, can we do it without having a backend?
Yes, you can build a fully client-side web app using JavaScript and libraries like TensorFlow.js for processing and visualization, eliminating the need for a backend. All data handling and simulation run directly in the browser.
Okay, so what would the web application workflow be like?
The web application workflow would be: first, you load the histopathology image. Next, you apply image processing and analysis with JavaScript libraries. Then, you visualize the results in real time. Finally, users can interact with or download the processed data, all without a backend.
So forget the downloading. We want the web application to be, yeah, the download is the low priority at the moment. We want to generate or load an image or have preset images. Then we want to do a image segmentation and stuff like that on it. Count cells, for example, or have a list of other processes we could do. So for example, counting cells, or what else? What can you recommend?
Along with cell counting, other processes include tissue segmentation, identifying tissue types, measuring morphological features like area or perimeter, and classifying tissue structures. These can all be handled in browser with JavaScript libraries.
Okay, can you elaborate on that? We eventually need a brief, a standalone brief for an experienced developer to generate, to make this web application, to build this web application.
Sure, start with HTML, CSS for layout, use TensorFlow.js for in-browser image processing, implement user interactions with JavaScript, and integrate OpenSeaDragon for image navigation. Keep everything client-side to ensure full functionality without a backend.
Okay, can we expand on it, actually describing what would be visible on the front panel?
The front panel would show the histopathology image, controls for processing steps, like segmentation or feature detection, and real-time visualization of results, such as overlays or highlighted regions. Interaction elements, like buttons or sliders, allow users to adjust parameters and view updated analyses instantly.
Can we be more specific on the front end? What will be visible on the screen? So I'm thinking you would have, would you have a single canvas just with the image and overlays, or would we need two canvases?
You can use a single canvas to display the image and overlay the segmentation or analysis results. Layers of transparency can be used to show results atop the original image.
Okay, that sounds good. And how about the controls? What type of controls will we have?
You'd have sliders for adjusting parameters, buttons to trigger analysis steps, drop-downs for selecting algorithms or features, and possibly zoom or pan controls for image navigation.
Okay, so specifically, what would the first control be?
The first control would likely be an image upload or load button, allowing users to import the histopathology image for processing.
We would like instead of an image upload, we would like to start with preset images. So there will be a selection of preloaded histopathology images. Then what?
Got it. Your front end would feature a drop-down or gallery for selecting from a set of preloaded histopathology images, and once selected, it displays in the canvas with overlay options and controls for processing.
Yeah, okay. What specific controls? Can you be more detailed, more technical?
Sure. Specific controls could include 1. A threshold slider to adjust intensity cutoff. 2. A segmentation method dropdown, e.g. watershed, k-means, and 3. A feature toggle for displaying cell boundaries or regions.
Hey, can you explain each one of those real quick?
Sure. 1. The threshold slider adjusts pixel intensity to filter regions. 2. The segmentation method dropdown lets users choose how to segment the image, such as watershed or k-means. And 3. The feature toggle shows or hides additional visual markers, like cell boundaries, on the image. Beyond segmentation and feature toggles, you can also implement a zoom and pan tool for navigation, an annotation feature to mark regions of interest, and a histogram or intensity control to analyze pixel distributions. Yes, cell counting is common, along with tissue classification, morphological measurements, and density analysis. You can also add co-localization analysis and morphological feature extraction. Sure, key features include cell counting, tissue classification, morphological measurements, density analysis, co-localization analysis, and morphological feature extraction. You can also include tissue segmentation and intensity profiling. Sure, cell counting detects and counts cells, tissue classification labels regions, morphological measurements quantify shape and size, density analysis measures how densely packed structures are, co-localization analysis checks spatial relationships, and feature extraction pulls measurable image attributes. Segmentation delineates distinct regions, and intensity profiling tracks pixel intensity variations. Each focuses on different analysis aspects. Sure, cell counting finds and counts cells. Tissue classification labels different areas, and measuring shape or size helps understand structures. Density tells how packed things are, and co-localization looks at how different parts relate spatially. Feature extraction picks out measurable traits, and segmentation highlights regions. These tools help analyze the image step by step, even if you're new to it. Of course, cell counting identifies and tallies cells, tissue classification tags different tissue types, and measuring shape or size gives details about structure dimensions. Density shows how tightly packed cells or structures are, co-localization explores how different features overlap, and feature extraction picks specific measurable traits like shape or texture. Segmentation divides the image into meaningful parts. This suite of tools helps break down complex images into understandable steps. Here's a brief for a developer. Build a client-side web application using HTML, CSS, and JavaScript, integrating TensorFlow.js for in-browser image processing, OpenCDragon for image navigation, and UI controls like sliders and dropdowns for parameter tuning. No backend required. Ensure modular code structure with clear interaction points and real-time visualization. That should give them everything they need to get started. Sure. Here's the full brief with technical details. Develop a standalone, client-side web application for histopathology image analysis using HTML, CSS, and JavaScript. Incorporate TensorFlow.js for in-browser image processing and analysis, and OpenCDragon for image navigation and zooming. Include UI controls such as sliders for threshold or intensity adjustments, drop-downs for selecting segmentation methods, e.g. watershed k-means, and toggles for displaying features like cell boundaries. Ensure modular code with clear separation of components, image handling, processing, and UI. And implement real-time visualization to reflect changes immediately. The application should be fully functional without a backend, ensuring all processing occurs within the browser. Would you like any further adjustments or additional details? You'll need to consider performance optimization for large images, user-friendly error handling, responsive design for different screen sizes, and efficient memory use to prevent browser slowdowns. Also, ensure cross-browser compatibility and accessibility features.
Hi, Rimzan. Are you interested in biomedical data science?
I'm here to help with your questions, including those related to biomedical data science. Feel free to ask.
Okay. That was perplexity. Potentially thinking a new web application on histopathology, if that's of interest. Oh, where's the chat? Because we need when to generate a brief. Where's the brief? We need the brief. Can you regenerate the complete? How does oh, it's still working. Oh, that's weird. Can you regenerate a complete brief with all the necessary details that we can send to the experienced developer? Don't include any code or any whatever specific libraries and things to use. We'll let the developer decide what to use. Oops. So what do we want? We want the brief for developer, no code. No code. We don't want any code. Do we want any code? No. Well, I mean, we will want the code. We'll just get a different developer to do it, a different tool. We will use a Gemini 2.5 Pro. Yeah, we don't care about the tools. Whichever model can do the job, we'll just use that. And we had this prompt. We had a prompt. Well, we had a prompt for everything. We need a specific prompt. Develop a single web page application. No, that was yeah, text instructions for developer, no code, single page interactive simulation / animation viewer. JSON for holding synthetic data, no React, no TypeScript, no Tailwind CSS, no Google APIs. Let's see. I mean, can we ask Perplexity to do it as well? I don't think it will be doing as good as Gemini. Happy to try. Happy to try. Project brief. Okay, let's run that. Shall we actually have... Can Gemini generate code? Maybe. Anyway, eventually everything we do is available on BioniChaos.com. Go check out the website. Let us know what you think. On the histology currently we only have this blog. The idea is that we'll turn it into an interactive web application. And Gemini did not generate code. No, it just keeps going with the brief. Gemini actually generating code. Thank you very much. And what should we call this? What should we call this? I mean, we can just replace the blog. That would be nice and clean. But no, just keep the blog as info for now. We'll keep the images. We have the 2 images. Where are the images? Where are the images? Histology. Histopathology. Oops. Histo. Histo. What should we call it? Any ideas? Any ideas at all? Yeah, Gemini is definitely not lazy. Yeah, histopathology analysis tool. That's a bit boring. Histo AI. Obviously, it should have AI in the name. Yeah, just do Histo AI for now. And we'll put index HTML because we are doing everything in a single HTML, which makes the source code just available directly on the page. Run it in a live server and we have a simulation. Let's see. What on earth? We have a simulation. We have interactive histopathology analysis tool, normal tissue tumor. Oh, right. There's a tumor, cell counting, tissue classification, segmentation, density mapping, colocalization, intensity profile, and morphological measurement. So say if we do morphological measurement, do a threshold, process image, and does it do anything? Does it do anything? One sec. One sec, give me a sec. You can see the screen. You can check the web application soon yourself. We'll pop it on the site. It did something. Okay, let's put it in demo mode. Let's put it in demo mode. Let's put it in demo mode. It's not doing anything. A contrast. Okay, it can change the contrast. That's nice. What else can it do? What else can it do? What else can it do? Okay, contrast works. Threshold. Okay, show overlay, enable sound. Yeah, we don't wanna hear it yet. It'll probably be quite bad. It will be quite bad. Okay, tissue classification, process image. Normal. Okay, tumor. Tissue classification. Immune. Necrosis. Does it make any sense? Does it make any sense? Does it make any sense? The demo mode should start after 10 seconds or so of inactivity. The demo should start. Beep, 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 beep. The demo should start. It doesn't do anything. That's a bit upsetting. 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 Yeah, we should be able to select the images like that. We should be able to select images like that. We should be able to select images like that. Yeah, we had a subscriber. Thank you very much. Thank you very much. Everything we do is available on BioniChaos.com. Again, there's some simpler things like this magnet simulation. But yeah, all the web application we make eventually available on the site for your convenience. For your convenience. They are available on the site for your convenience. Let me know if there are any questions. We are making web applications. They're available on our website. Why am I on this website? We are live streaming on YouTube. You can check the YouTube stream. Don't forget to subscribe, smash that like button or unlike button. There's no unlike button, so bad luck. There was ages like 20 years, yeah, like 10 years ago. There was a dislike button, that's for sure. Apparently they removed it. I can see still, yeah, I think it's still there, but it's like hidden. I don't know. Anyway, they removed it to protect whatever mental health. Okay, where were we on the histology stuff? So I had this blog on histopathology. We're not gonna go into the details of that. We need to fix. So Gemini made this web app for us. Made this web app. It made this web app. Is it working? Does it have any errors? Forgot to check for errors. I forget to check for errors. Errors. So it got the idea, and we can do, how about we do a more realistic image? We want to do a more realistic image. What do we call it? Histo AI. So no errors. That's good. We have a bunch of images. We have this one, that one. They're fake, AI generated, as everything else. These days. But they are good because we can do some image processing on them, see what's what. So it should not look anything like that. It should be different. It should be different. I like the idea. So we'll have the histo image. Then we can do all these things on it. Well, the synthetic stuff is actually nicer because we can test it. We can test it. Test it. Yeah, the demo doesn't do anything. There seems to be something missing in the code. How to use. Select a simple use drop-down menu. Yep, zoom, pan, choose analysis, cell counting, density mapping, adjust parameters. Yep. Process image. Show overlays. Play demo button to see an automated tour of the tool's features. That's exactly what it should do. Just don't think it actually does it in a good way. The demo will start automatically after 10 seconds of inactivity. Yep. Single file architecture. Yep. Client side. Yep. Canvas rendering, synthetic data. Yeah, so we don't want to. Yeah, normally histopathology slices are very large files, a high resolution, lots of details. So maybe we don't use one of those. That's why synthetic data is so good, because we can actually test things. Okay, future directions. A real image support. Yep, we'll do it later. Machine learning integration. The modular analysis problem is designed to align the future integration of client-side machine learning models. TensorFlow.js. Are they pre-trained models or? And unfortunately, we can't do the chat. The compare mode. Yeah, wish you could start the voice conversation based on this. You probably could. But we have to copy the code. Okay, give it to a voice model. Still thinking. Thinking. It will take some time, wouldn't it? It's still thinking. What is it thinking forever for? Wait, when I hover over, it should not stop the demo mode. I think now it might be stopping it. Maybe not. Who knows? It's reviewing, summarizing, exploring, synthesizing, synthesizing findings. What? Can you give a brief overview of the code?
Cell counting and density mapping, allowing
Okay,
users
can
to
you overview the
interact
code
and
for
adjust
like a
parameters,
beginner?
all
For a
running in
beginner?
the browser.
Wait, can you overview the code for a beginner? Hey, don't go into the technical, so don't mind the technicalities of like HTML, JavaScript, whatever. Just overview the idea behind the web application.
This web application is a tool that lets you look at images, like samples of tissue, right in your browser. You can zoom in and move around, and it lets you simulate different kinds of analyses, like finding the number of cells in an area, and shows you the results on top of the image. It's a way to interact with the image and see how different tools work, all within your web browser.
Okay, that's nice, but well, first of all, the demo doesn't seem to do much at the moment. So is the demo complete or not? Can you review?
The demo is designed to automatically cycle through the different analysis modes and image samples to show a brief overview of the tool's features. It's an automated sequence that shows the types of things the tool can do, rather than a step-by-step tutorial for a beginner.
Wait, so the demo mode meant to be cycling through the different analysis modes? Because currently it doesn't seem to do that. Can you?
Yes, the demo mode is supposed to automatically cycle through the different analysis options. If it's not doing that, you might try clicking the Play Demo button again to restart it.
So again, the demo mode meant to be cycling through the different analysis modes and then processing the image every time, or what?
That's correct. The demo mode is set to change the selected analysis mode, sometimes adjusting the threshold slider and then pressing the Process Image button automatically before moving on to the next step in its cycle.
Okay, and is it working correctly at the moment? We need to ask the developer if it's working okay or not.
If the demo mode isn't cycling through the analysis modes as expected, there could be an issue. It is a good idea to check with the developer to verify its current behavior and make sure it's functioning correctly.
Okay, so contrast seemed to work well. The threshold, I don't know what the threshold is doing. I mean, the threshold is setting. Wait, but the threshold is so every time we change the threshold, we need to click process image, or why the image? Can the image be processed on the fly? Like actually, as we change the sliders, can we process the image?
The way it's set up right now, you need to click the Process Image button after changing the threshold to see the new results. Processing is a separate step from adjusting the slider. Making it process on the fly would require different code logic, but it's something that could be added later.
Okay, can we include, we do want the processing to happen on the fly, and we want the demo mode to work properly as discussed before. We wanted to actually scroll through all the different analysis types, cell counting, tissue classification, and actually show what it does. Keep changing parameters and analyzing the image on the fly, so showing the difference it makes. Can you write the full brief with all these questions and requests to the developer?
Certainly. Here is a brief to the developer detailing the requested changes. Please implement the following modifications to the application. 1. Enable on-the-fly processing. The image should be automatically processed and the overlays updated as the user adjusts the threshold slider, without requiring the Process Image button click. 2. Ensure the demo mode functions correctly. The demo should automatically cycle through the different analysis modes and parameters, demonstrating the on-the-fly processing of the image. This should clearly display the effects of changing the analysis type and the threshold setting. Thank you for your assistance.
Okay, and so we are removing the process image button, are we?
Since the processing will happen automatically when the slider is adjusted, the separate Process Image button can be removed from the user interface. This would streamline the interaction flow.
Okay, we have the thing running already. So wait until it generating the code. We will wait until it's generating the code. One sec. Okay. Yeah. So you can join the stream if you like chatting. If you like chatting, that would be good. We don't have much. We'll be here another hour. Probably take a break, come back. Everything we do eventually is on BioniChaos.com, like this magnet simulator. So go check it out. A prosthetic arm, a demo running as well. You can see how prosthetic arms work. There's even sound. Should be even sound to it. And what else were we doing? The MRI. I have an MRI simulator. I can talk about that in more detail. But currently we're doing the histopathology. We had a blog on it sitting there for quite some time. But now we're trying to turn it into an interactive web application. Interactive. And we obviously not coding anything ourselves. Obviously we have AI coding for us. Thank you very much. And let's do another version of it. Let's do another version. Well, so we don't lose the previous thing. It's almost 1,000 lines of code. Let's see. We still have the... Wait, what? Wait, what? That's weird. That's super weird. One sec. One sec. Ooh, got my microphones and everything stuffed up. Ah, yeah. Yeah, testing AI. We're using AI to develop these web applications. So this one's measuring my blood pressure using the camera. But yeah, if you move and stuff. It's looking at, so someone is asking, wait, I can bring it on now. It's not like, I have the whole videos, like all videos on it. What? I sent you a link to the YouTube channel. You can check my YouTube channel. I'm live streaming at the moment. You're not on the stream. Well, mainly because you're using profanities and stuff, so I can't even bring you onto the stream. But even if you wanted to, but I'm developing this live. It's working. It's actually working. It's actually working pretty well. I'm also a biomedical engineer. I got a PhD in biomedical engineering. So, and I was testing the videos. Yeah. Yeah, I made videos of me using it. So if you don't move, you control the light in the room. You need another light actually. Uh, and then you stay still. It's actually measuring it correctly. Like I was comparing it to a smartwatch. And then you can do your Are there any questions in the chat? There's no questions in the chat. Okay, this tool is actually working better now. What if we still have process image button, even though it's processing on the fly. We can continue chatting with a bot. Hey, wait a sec, the button wasn't removed. We keep the button. Wait a sec. Did I share the code? Wait. To share the code. Run it again.
I've removed the process image button, as the analysis will now update automatically with the slider.
Hey, can you check the code? The button's still there, right? So we have another developer coding for us. So can you just comment on what they have done compared to the previous version?
The Process Image button is still in the code, but it has been commented out. This is because the analysis will now run automatically whenever the threshold slider is adjusted, making the manual processing button redundant.
Okay, so it was commented out from the JavaScript, but it's still on the front panel. It's still in the HTML, is it?
You are correct. The HTML structure still includes the button tag, but the JavaScript code has commented out any functionality related to that button. This means that while the button might still be visible in the browser, it has no active code associated.
Okay, can we actually prompt the developer? We either removing that button or keeping it there. So if the JavaScript the code for this button is commented out, we then might as well remove the button. Can you turn it into a prompt for the developer? Also, can you see anything else wrong with the code? So the demo seems to be running better now, kinda. It does cycle through the different analysis modes. But then we probably need a text box with an explanation of what we're looking on the screen. So can you turn all this into prompts? Can you turn them into prompts for the developer?
Okay, here are some prompts for the developer. First, regarding the Process Image button, please consider removing it from the HTML structure, since its functionality has been replaced by the real-time
we're
processing
removing
with the slider.
button
Secondly, for the demo mode,
for the
it would be
demo mode.
helpful to add some text or
Yeah, I'll
overlays
do
that
text overlay
explain which
explaining
analysis mode is currently active and what we are looking at on the screen as the
what's
demo
happening.
progresses. This would make the demo more informative and understandable for the user.
Okay, one sec. I will mute that. Unmute this. Sorry. Yeah, I have too many sounds going everywhere. What were we doing? Yep. Okay, now we're hearing some annoying music. Wait, I'll have to mute that. One sec. So we are live on here as well. If you want to join in the conversation, blah 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 blah. We're developing web applications like what you can see on my face. Currently, we're doing histopathology simulation with AI. So that's what we're doing at the moment. We have a bunch of robots actually doing it for us. And we have this prompt that we need to give to another robot. I'm like already get confused with all the following enable the on the fly person. That's the previous thing we did. Yeah, so we're cycling now through the different analysis modes. That's okay. Okay, we have another prompt. So in theory, it should modify the it should modify the code straight away. Maybe not. Get to like, subscribe, unsubscribe. You know what to do. And mainly after technical comments. So if you're interested in biomedical data science, engineering, web development, AI, this is a good place for you to be. And every feedback will be eventually turned into prompts for future web applications. Maybe. See how we go. That's no promises. No promises whatsoever. Should be disclaimers, everything. Do not use this for any medical reasons and blah blah. Mainly using synthetic data anyway. Wonder what percentage of people actually did histopathology, like have actually sample been taken for histopathology. And I don't know, that would be 1% of population, I guess, maybe, I don't know. Now question is how many would have actually had the data available to them. This will be one of those things be almost impossible to get. Okay, so we updated the code. Let's see. The demo mode should just start after 10 seconds or so. Okay, cell counting, highlighting detected cells. The slider adjusts sensitivity. Okay, segmentation, outlining large structures, high values isolate only, blah blah. Density mapping, visualizing cell clusters. Red indicates higher density. Was it? It didn't seem to be correct, but okay. Okay, cell counting. Okay, so it's just cycling through the thing. That's fine. Segmentation. Oh, the gain, the system. Oops, sorry. The system keeps adjusting the gain of my microphone, so I have to speak louder and louder. Large structures. Is it cycling? Oh, yeah. So the tumor. I have a tumor density mapping. It wasn't corrected, or was it? Okay, let's do again the same thing. So we'll have the code. We'll pop it to the chatbot. Well, the voice model, whatever it's called. Okay, I actually shared the updated version of the code from the developer. Can you look at what was changed? Provide like a summary of what was changed?
Sure, I can analyze the new code for you. Just paste it in, and I'll compare it to the previous version to summarize the changes made.
Yeah, I just pasted it. Wait a sec. Didn't I paste it in? Hey, wait, here it is.
No
Here it
worries.
is. Just realized that
Okay.
my camera was frozen.
Thank you. I see the code now. It's a single file containing HTML, CSS, and JavaScript. I'm comparing it to the previous version now to summarize the changes made. I'll let you know what I find.
When it says that there's no way you're coming back to me, are you? Can you just review the code?
My apologies for the delay. I am currently analyzing the differences between the two versions of the code.
Yeah.
I will let you know when I have a summary ready. Is there anything else I can help you with while I'm working on
This
this?
is really weird that it does it. It's really weird because it's not actually analyzing anything. It's super bizarre. Wait. Okay, are you like 10%, 50%, and 80% through analyzing the code, or what?
I'm making good progress. I've identified the main areas of change, including the removal of the Process Image button and the implementation of real-time analysis with the threshold slider. I'm just finalizing the details to provide you with a complete summary. I should be done shortly.
Is it really doing it like that? highly doubted. Highly doubted. There's no way. It's not doing anything. Pretty sure. I don't know why it even says it. It's really weird. It's not to do with the model. It's to do with how it's like how it's being implemented, kind of thing. Okay, are you done reviewing the code?
Yes, I'm ready to provide the summary of the changes. The main changes involve removing the Process Image button and implementing
correct.
real-time analysis whenever the threshold slider is adjusted. This eliminates the need for a manual processing button. Additionally, the demo mode has been updated to demonstrate this new real-time processing functionality. Is there anything else you would like me to comment on?
Okay, can we actually look at that processing, so the analysis? So for example, when it does segmentation or when it does density mapping, it doesn't seem to be like, is it actually just a demo, or is it real, or is it doing is there something missing in the code in terms of doing that analysis, or is it just pretending to do it or something?
Based on the code, the analysis is simulated using synthetic data. The functions like segmentation and density mapping don't actually process a real image, but instead they use the predefined synthetic structures to generate overlay data based on the threshold slider. This is a common practice for building prototypes.
No, that's fine. So I get it's generating synthetic data. That's perfectly okay. I'm asking if the analysis is actually correct. So is it actually taking the simulated data and processing it properly? Can you comment on that?
Ah, I see what you mean. The analysis is performed on the synthetic data generated by the code. Assuming the synthetic data structures are designed correctly to represent realistic scenarios, the processing correctly applies the defined logic for segmentation and density mapping based on the threshold value. However, this doesn't guarantee the same functions would work effectively on real-world noisy image data. Does that clarify the situation?
Yeah, I want you to elaborate on that. Can you give a specific? Can you give me a specific example?
Sure. In a real-world image, there might be variations in lighting, different textures and colors within the segmented area, or even occlusions. The simple synthetic data in this code, which is just a basic shape of the tumor, doesn't really represent that complexity. So the current analysis might work well on the perfect synthetic data, but the same logic might not correctly identify the tumor in a messy, real-world image. Does that make sense?
Yes, but so first of all, how can we improve it? Second, so what specific, like, the analysis is correct for the synthetic data? So, I mean, the synthetic data is like simplifying the images, right? But then the analysis should still be legit. Can you explain? Can you explain that?
You're right. The analysis is logically correct for the synthetic data given. It does apply the defined rules properly. The issue with improving it would be making the synthetic data more realistic and the analysis algorithms more robust to handle the imperfections and complexities you'd see in real images. So, while the code's logic is good for its current purpose, it would need significant changes to accurately process real images with complex features. Would you like me to explain ways to make the synthetic data more realistic, or focus on improving the analysis algorithms for such realistic data?
Wait, without changing the input images, so we want to use the synthetic data, that's fine. How do we make sure the analysis is actually correct, even if the data is synthetic? So sorry, so just like rephrasing it. I know I've been asking the same question over and over again, but can you explain it in detail to a beginner?
The analysis is considered correct if it accurately follows the defined rules. For the synthetic data in this code, correctness means the segmentation and density mapping precisely match the predefined structure of the tumor based on the threshold setting. To ensure this, you would compare the output of the analysis with the known ground truth of the synthetic data. If they align, the analysis is considered correct within the context of the synthetic data. Does that help clarify what we mean by correctness in this context?
No, not really. Needed repeated. Needed repeated. I'm not entirely sure. So wait a sec. When we using each analysis mode, so cell counting, tissue classification, segmentation, whatever, we need to clearly see. Let's try it manually. So we have tumor tissue supposedly. We're using segmentation. We're changing the threshold. Okay, so the threshold, at some point, it's finding stuff that's not actually there. Wait a sec. So the overlay, yeah, there's a problem. There is a problem. One sec. There is a problem that the analysis, the overlay is not actually segmenting the existing data or something. There's some issue with the analysis. Can you rephrase it into a question to the developer of what's going on, keeping all the technical details there?
It sounds like you've noticed an issue with the analysis, specifically the
Yeah, it sounds
segmentation
like we
overlay,
noticed an
where
issue with
it
the
sometimes
analysis.
appears to show positive results where there isn't visible synthetic tumor data in the code. Could you please explain why the segmentation overlay might be displaying this way at specific threshold settings, even when the synthetic data is clearly defined in the code? Is there a discrepancy between the synthetic data structure and the analysis logic?
Okay, let's try that as a prompt for the developer. There seemed to be a problem. Oh, by the way, the demo should stop. Wait. Oh, come on. Really? The demo should stop when the user is interacting with the page. Wait. So we have this normal image. We have it. Really? They're meant to be a tumor. There's something. It stuffed up the code or something. Something wrong. Something is wrong. That's not fun. It removed the tumor or something. It meant to be there. It's still detecting it. So next segmentation. Yeah, it's giving me all the details and stuff. Let's see if there are any errors. Oh, now I can see it. What on earth? Right, so it's randomizing the thing. Okay, I think it was just tumor. It's like not fitting the screen or something. Oh, I have no idea what's going on. The demo seemed to work okay. The demo seemed to work okay. There's some bug to the thing. There is some bug. There is a bug of when the tumor is meant to be displaying, it's not actually visible on the screen, so it's labeling stuff, so the overlay shows stuff that is not actually being shown in the original synthetic data. I don't know why. There is some bug. Can you write a prompt for the developer to fix it?
Can you please fix the segmentation overlay so it accurately maps the synthetic tumor data as intended? Currently, it sometimes displays positive results where the tumor is not visible in the synthetic input. This can be confusing for visualizing the analysis results.
One sec. Sorry, what were you saying? I'm talking to a robot. Mute. Yeah, Gemini, take the tag off this guy. That's actually fine. Yeah. Gemini, take the tag off. Wait. So we have a prompt. Can you please fix the segmentation overlay so it accurately maps the synthetic tumor data as intended? Currently, it sometimes displays positive results where the tumor is not visible in the synthetic input. Yeah, that sounds legit. Need to fix any other bugs as well. Need to fix any other bugs. Do we need to generate complete code? Generate complete code. Now someone said Gemini take this tag off this guy. I think if Gemini will be able to do it, that's proof for AGI. But try it out. Good luck. I mean, send Gemini the stream. I mean, it can view the stream and everything, and make Gemini to take off the tag of my face. Maybe it will work. Sorry, I can't. Wait. Someone is asking about the motivation of this SHIT. It's a very hard question to answer. It's like it's it's in the eye of the beholder. Yeah, the motivation. Motivation. Everything we do is available on BioniChaos.com. Go check out the website, provide your feedback. Any technical feedback that you provide will end up as prompts. The narrative and the motivation. So we're making biomedical data application. What we're trying to do is for you to actually take control of your medical data. If you objective, not objective. We're not objective. We're using are we objective? No, we're not objective. Motivation. Poof. Yeah, if you weren't swearing, we could bring you live on my YouTube channel or something. I'll explain the motivation and stuff, but you seem to, if it's objective, no, it's not objective. We're doing like robotic arm simulation, so obviously it's a synthetic. We're mostly using synthetic data, showing you like how things work. So we're trying AI for like doing magnet simulations and things like that. I don't know if you can see the screen. Okay. I don't know if it's the use of AI that gets people going or something, but not sure. Anyway, now we're doing this histology simulation. So those are also fake images that were generated with AI with quite a while ago. We probably can do better ones these days. Okay, we'll mute that for a sec. We'll just continue talking to the robot, because the robot is not swearing and it's behaving itself very, very nicely. How good is that? So trying to fix this. What were we fixing? A segmentation of, right. So when we moving to tumor, it was not actually showing the tumor. It's finding it, but it's not showing it. So it's stuffed up the code. We have a complete code. Let's give it another copy. Doing our own version control. That is not a real version control. By the way, if you put the comments in, if you put the comments in the YouTube chat, I could respond to it. Copy to clipboard. Okay, we have now version of the code. Another version of the code. It's 943 lines at the moment. It's like crazy. Okay, let's see. Restart. Okay, we need to check. Where on earth? Mueller. Tumor. There meant to be tumor somewhere. Cell counting. Yeah, it's meant to be here. What on earth? Is there errors? Are there errors? No errors. What's happening? It's like one of those basic things. So it will generate a synthetic histopathology image. You can do your, say, cell counting. And when you select a tumor, it will show you a tumor there. But yeah, it's not actually there. As in, the cell counting algorithm will find it. But the original... Oh, come on. How do you even explain it? How do you even explain it? It's a bug. It's a bug. It's doing tumor segmentation and everything. Whereas the thing is not in the original. It's not in the original generated image. Let's try. Let's try. Let's try. Stream is still live. Okay, we haven't updated code for the developer, but there is a bug. So the bug is that in the tumor version of the image, the tumor is not visible in the originally generated image. It's only visible in the detection, in the analysis mode, in the overlay. So the overlay is showing the tumor, but the original image is missing the tumor. Can you write a prompt for the developer on that?
I understand. You want the original synthetic image to consistently display the tumor so it matches the overlay in the analysis mode. How about asking the developer, could you please ensure that the synthetic image always displays the tumor so it's consistent with the overlay in the analysis mode? Currently, the tumor is sometimes missing from the base image. Would you like me to put this into an email for the developer?
It's not sometimes missing, it's always missing. And it's not always meant to be there. It's only meant to be there when we're selecting the tumor version of the sample. Now it's an obvious bug, so if you can be more assertive in your prompt, that would be great.
Acknowledged. Here is a more assertive prompt. The original synthetic image consistently displays the tumor incorrectly, as it is not visible in the image itself, despite being present in the tumor version of the sample. This results in a clear mismatch with the segmentation overlay. Please urgently fix the code to ensure the synthetic image accurately displays the tumor when the tumor version is selected. Would you like me to include any specific code snippets for reference?
Hey, no, we don't need the last bit. Just need the prompt. We need the prompt. Copy pasting is a skill, isn't it? Copy pasting is a skill. We need to regen whole code. Everything we do eventually available on BioniChaos.com. Go check it out. Provide your feedback. Have you seen the lilac chaser illusion? Speed. Yeah, for me to optimize for the illusion, I need to do something like, well, I can see it. So if I focus on that square, on the, not square, the cross, I can see the green thingy, the green circle. Do you see a green circle? Do you see them? They're here. They are here. So you can change the parameters to optimize the illusion for you. Yeah, it's getting kind of stronger. Well, even if I know it's not there, well, it kind of is. You can check it out yourself. You can check it out yourself. What's the motivation? Motivation. Ooh, okay. What? We have updated code. Wait a sec. Let's stuff something up in copy pasting. No. The tumor appeared eventually. The tumor appeared eventually. The tumor appeared eventually. Do we have the whole code? 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 Bim, 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 bim. Okay, let's see. Tumor. Ah, come on. What did it say? What did it say? Yeah, recognize the bug. Of course it did. The synthetic data of the tumor was being generated in a way that made it nearly invisible. Okay, it's still invisible. Let's double check. Normal. Okay, there's something there. Oh, we need to fix the code. We need to fix the code. Any errors? Are there any errors? There are no errors. There's still an error. There's still an error. Okay, it's there now. It's there now. Don't get it. Need to fix the demo as well. So this model, the voice model is not that great, is it? It won't be able to find the problem, but we can chat to it. So it actually so we can generate a proper prompt for the other model to fix the code. Oops. Did dynamic slider enhanced demo. I don't know. Generating the whole code. Generating the whole code. Why is it generating the whole code? I don't know. Should be better than what we had. Okay, so we have the normal. It's as if the whole sample is not. What? Okay, there seems to be a bug when we're changing any of the parameters. Can we make sure the canvas is updating? So, for example, when we're selecting a different sample, we need to make sure the canvas is updating properly, because currently I don't think it is. Also, when the user interacts with the page by clicking on something, not just hovering, but clicking on something, we should be able to stop the demo mode. We need to stop the demo mode when the user is interacting with the page. We need to stop the demo mode when the user is interacting with the page. We had the voice model. We had the code model. Like my phone. Wait a sec, what were we doing? Okay, fix the code. Let's fix the code. It fixed the code. Did it? Image select. We need the complete version as well. There's something in the styling. No. Is it generating complete code or not? Yes, it is. That's nice. That's nice. Did it finish? Did it finish? Wait a sec, one sec. Have to unmute this, mute that. The overlay here on my head meant to if I don't move and I control the light in the room, it will actually measure my blood pressure. But sometimes work. But I keep moving and talking, so it's just showing noise. It's all JavaScript. It's all on my website. So everything we do is available on BioniChaos.com, and all the development is live streamed on YouTube. And we're doing optical illusions as well and things like that. Magnet simulations, robotic arms, prosthetic arm, interactive demo. So we have a demo of an MRI, obviously synthetic MRI. And now we are trying to do this histopathology thing. Oh. Yep. So developed with AI. And yeah, the bot keeps stuffing it up. It's more prone to original static image. Some obvious. Shall we start a new chat? And we'll give it the code first. We'll give it the code. Hey, can we make sure that when we change any of the input parameters, the canvas is actually updating? That's one thing. And also, when the user is interacting with the page by clicking on any of the inputs, we need to stop the demo mode. I mean, the demo mode needs to stop automatically. Okay, so we had some review of the stuff, simulating analysis, real-time technical code quality analysis. Yes, vanilla stack, procedural data. Okay, have JSON file objects. Okay, I'll try this prompt. Make change of the input parameters. Yep, we'll try that. Need to regenerate the whole code. We need to regenerate. Is it gonna regenerate or give out the segment samples? Yes, we have the new code. Hopefully it fixed the bugs. Do you think it fixed the bugs? Okay, it's almost 1000 lines. So it's promising that way. Okay, so we have the tumor. Normal. Is cell counting. Can change the sensitivity. That works well. That works well. Contrast, contrast, contrast. Is it actually... So wave sensitivity of 100, it should be counting all of them. Is it? Oh, maybe it is. It's just the yellow color. The yellow color is not helping. Tissue classification. Meant to have labels. The labels are colored. There's some sort of white. White on white is not great, is it? White on white is not great. Tissue classification. Okay, so it seemed to work. The cell counting seemed to work okay. But then tissue classification, it has those labels, white text, and we have a white background, so that is not great, is it? Okay, tumor segmentation does work, kind of. Okay, might finish it next time. It's will become available for you on the website as well for you to check out the prototype. Well, everything is a prototype, really, especially this one. Especially this one. What happened to the demo? What happened to the demo mode? One sec. The demo mode is not starting. It meant to be starting after 10 seconds. It's not starting. It's not starting. It's not starting. Why is it not starting? Ah, Gemini stuffed up my code. Gemini stuffed up my code. Gemini stuffed up my code. No, the demo mode should be starting automatically as it was before. Yeah, and if we can check for any other errors, that will be good too. Okay, we'll try those. I like how Perplexity keeps transcribing. I like how Perplexity keeps transcribing. Yeah, that'll probably be last prompt. Last prompt. It's gonna regenerate the code. Didn't understand demo mode auto start. Yeah, my last change to the demo logic was a bit too aggressive. Yeah, you bet. You just got rid of it. You just got rid of it. The logic simplification for the demo mode also cleans up the code. Very nice. Thank you very much. Here we have the code. We have the code. 957 lines. What? Still the same. Tissue, normal, tumor. Okay, tissue classification, cell counting works, contrast works, overlay works. Yeah, we don't want the sound. And the demo should start automatically. And the demo should start automatically. Density mapping. Okay, I'll have to finish. We'll have to finish. And start again tomorrow. I'll see you next time. Go check out the website. Everything you do is available on BioniChaos.com. Go check out the website, provide your feedback, and I'll see you next time.